Exponents are a shortcut for repeated multiplication. So if I wanted to multiply a times a times a times a, where I have 4 factors of a, I can write that as a to the 4th power. So let's look at some more shortcuts that we can take using exponents. If I wanted to multiply 2 to the 3rd times 2 to the 4th, I could rewrite this as 2 times 2 times 2 for the first exponent. I have 3 factors of 2 times 2 to the 4th power. So 4 factors are 2. 2 times 2 times 2 times 2. So altogether I have 7 factors of 2. If I multiply that out, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Or I could use the product rule for exponents. That is, if we're multiplying, if you have the same base to multiply, we keep the base and add the exponents. So we can do the same, evaluate the same expression, 2 to the 3rd times 2 to the 4th, by simply keeping the base, which is the 2, adding the exponents. So 2 to the 7th, 2 to the 7th is 128. So if we wanted to divide, I have 5 to the 5th power divided by 5 to the 3rd power. I could rewrite this as I have 5 factors of 5. 5 times 5 times 5 times 5 times 5 over 5 to the 3rd power. 5 times 5 times 5. Then simplify. 5 over 5, that's a factor of 1. 5 over 5, that's 1. 5 over 5, that's 1. I'm left with just 5 times 5. Well, 5 times 5 is just 25. Or I could use the quotient rule for exponents. That is, if we're dividing using exponents, if we have the same base to divide, we keep that base, subtract the exponents. So, to look at this same example, 5 to the 5th power over 5 to the 3rd, I can just keep the base of 5, subtract the exponents. And I end up with 5 to the 2nd power, which is 25. Another rule when we use exponents is the zero exponent rule. Whenever you raise a number to the 0 power, the answer is always going to be 1. So if I have 7 to the 0 power, that's just 1. Now the exponent only goes to the number that it's next to. So here, it's only the 7 that's to the 0 power. So I'll bring that negative down. So 7 to the 0 power is 1. So my answer would be -1. If I have -7 to the 0 power, that's a little different because this whole -7 is bonded together. It's like crazy glued together. It's in parentheses. So this whole -7 is to the 0 power. So that whole thing is equal to 1. All right, now if you have a negative exponent, such as a to the -m, this just means to take the reciprocal of the number. So I'll put that over 1, and the reciprocal would be 1 over a to the m. Or if I have 1 over a to the -m, that negative exponent just says take the reciprocal of it. So I have a to the m over 1, or just a to the m. So if I wanted to evaluate 4 to the -2, well, I could just put it over 1, so I can take the reciprocal of it. It's 1 over 4 squared, or 1 over 16. Now, if I wanted to evaluate 3 squared to the 3rd power, I could take that 3 squared times itself 3 times. So 3 squared times 3 squared times 3 squared. You see where I have 3 factors of 3 squared. Then expanding each one, well, 3 squared is 3 times 3. Again, have another 3 squared, so 3 times 3. And another 3 squared is 3 times 3. So I end up with is 6 factors of 3, or 3 to the 6th power. Which is 729. Or I can take a shortcut. It's the power rule for exponents. If you're raising a power to a power, we'll keep the base, in this case the base is a, and multiply the exponents. So let's do this same expression, 3 squared to the 3rd power, using the power rule. So I'll just keep the 3 and multiply the exponents. 3 to the 6th power, or still 729. All right, let's look at a couple expressions. If I wanted to evaluate 3 to the -4 times 3 to the -1. Well, I'm multiplying, so I can use, with exponents, so I can use the product rule. To use the product rule, we keep the base and we add the exponents. I get 3 to the -5. Well, we never like to leave an expression with a negative exponent, so I'll use the negative exponent rule. Put this over 1, and that negative exponent says to take the reciprocal of it, 1 over 3 to the 5th. So it's 1 over 243. If I want to evaluate 5 to the 3rd power to the 0 power, okay, well, because this 5 to the 3rd is in parentheses, that whole thing is to the 0 power. Well, anything to the 0 power is just 1. Okay, if I have 3 to the -3 over 3 to the -2. All right, well, now I have the same base and I'm dividing, so I'll keep the base, I'll keep the 3, subtract the exponent, so it's -3 minus a -2. Well, that gives me negative 3. That negative minus the negative would be plus 2. That's 3 to the negative 1. And remember I just said we never want to leave an expression with a negative exponent. So it would be 1 over 3, taking the reciprocal of it.